So this question is one of the initial samples that came out about 10 years ago, about the time that they were starting to introduce the syllabus. And most questions now are similar standard, maybe even a little bit easier. Basically, if you could do this question, we're able to do most questions. Okay, so today we're going to cover part A and part B. We might leave part C for another day. Okay, so the first thing we want to do is look at the scale. So the scale is 1:2, so this will become 100. This will become 110. This will become 7.5, which is a bit unusual, but anyways, this is 20 and this is 50. Okay, so it's quite a bit in this question, and then this 150 becomes 75. So the first thing we'll do is we'll read the question. So what it says is, figure B3 shows the plan and elevation, so there are two views. A 3D graphic is shown, okay, so that's this. The main body of the trophy is made from a hollow glass with a golf ball inside, so that's why we can see this circular shape here. The base is elliptical, okay, so the base is this, okay, so if we look at that, that's basically this shape here. So that's an ellipse, okay, so we'll underline that. Base is elliptical, and the upper portion has been shaped as shown in the elevation. Now we're just going to cover a simple principle, and this is that you can see here that the cut is parallel. Okay, so I've shown a slideshow that will basically show that if we cut a cone at the same angle as the outside of the cone, okay, then we get this shape here will be a parabola, or basically this shape here will be a parabola, or looking in it at 90 degrees will be a parabola. Okay, so that's going to affect how we're going to draw part B as well, but or where we're going to position it basically. But the other thing is, if we cut it at a steeper angle, right, it's going to be a hyperbola, and if we cut it at a shallower angle, it will be an ellipse. Okay, so just an important piece of thing to be aware of. Sometimes they'll give you a hint, sometimes they won't tell you that. So it says draw the elevation plan of the trophy, and then it says draw the development of the cut surface. Now in order to draw the development of the cut surface, we're going to need a bit of space up here, so hopefully this will fit on this page. What we'll do is we'll try to keep this down as low as possible, and then we'll see if we have space. If we have space, we'll do part B. If we don't have space, we'll leave it. Okay, so the first thing that we might need to know in order to position it is basically what distance is this. So this is basically the top of the cone. Okay, now obviously we're only seeing this much of it because it's being cut at an angle off. But what would the radius of the cone be, or what would the diameter of the cone be? To be the same as what this is here. So that's 100, so basically it's radius 50. Okay, so what we're going to do is we're going to come up maybe 60 from the bottom, and we're going to keep it close to this side here. Okay, so up 60 from the bottom. I'm going to mark a center line there, and we want again at least 50 this way. So what I'll do is I'll put that point there, so I just roughly line that up with the writing, and what I'll do is I will come back in 50, and then I'll draw my crosshairs. Okay, so I'm going to take my compass and I'll draw this semicircle first. Okay, now the other alternative, what you could do is draw the ellipse if you want first, just so that you wouldn't get confused. But I'm just going to draw this bit here first, just in the hope that people understand how I got this measurement. Okay, so I'm going to draw that like that. Okay, I'm going to come back to the ellipse in a few minutes. Okay, and I'm going to heavy this in. Okay, I'm not going to worry about these circles here for the minute. But what I am going to do is I am going to draw the elevation. Okay, so I leave a gap of maybe about 10 mil. And draw a ground line. And then we'll come up 7.5. Now what's unusual is I'm highly surprised that they'd ask 7.5 in an exam now. Alright, I would imagine they wouldn't ask. I'm just using my set square. The alternative way, the exact accurate would be measure 15 and then bisect it, but I don't know if that's what they expected to do. It's a bit of an unusual one. So we know that half of this is 50, so half of it's 25. So what I'll do is I'll start to mark it. Okay, and I'm going to use that distance there when I'm using it for drawing my ellipse. Okay, ideally what I should do is draw it in plan and then bring up the points, but we'll assume that we're fairly accurate. Okay, and then we have a width of 20 here, so that's 10 out either side. And then we have a height of 110. Okay, so we might be able to do part B, but I'm not 100% sure at the minute. So this is basically, we'll just show how I got this. This is this here. Okay, so that's basically how I knew to set this to 50. Okay, so we can draw this way. And just heavy these in so that they're seeable. And then my last part is to draw, well, I can heavy that line there, to draw a parallel line to this. Although firstly I'll have to draw in the other side. So again it's 50. I'm going to draw this slightly here first. And then we'll do our sliding sets first. Okay, again you could use your adjustable set square. Okay. So we now have the elevation for the most part, but what we don't have is the sphere in the middle. So what we want to do in order to get this point is we can bring this across here. Okay, the central point will be straight across. And because they're parallel, that will be the same as bisecting it. So because that angle there is just the opposite of that, that's why that works. So in order for us just to show the point of contact, again, if you have an adjustable set square, this will be a lot more accurate. Just mine doesn't tend to fit in here. Maybe I'll use an orange or slightly different color. Okay, you can move that across the 90 degrees, or alternatively, you can do the same here. Okay, technically do the same on this side as well if you want to actually show all points of contact. But that's just to get me the exact radius. I need to show one of them. I don't necessarily need to show them all, but instead I just show up one in here. So any of those will work, and that will give you the exact radius as to what to do the circle to. So if you touch, you should see it should work for all of them. I've somehow made a hole in my page, which is made it a tiny bit off. And hopefully for the main part it's okay. So that's that. So at the same time I'm going to draw the plan view of that. Okay, so that's different to this point here. And that's why you see a small gap between there, but the thickness of my pen or my marker isn't helping. Okay, this is going to be the hidden detail because this is the base. So again, my hidden detail probably could be a bit more even, but the main points are there. It's just, again, it's just the thickness of the marker. So I have this ball in. And what I want to do now is I want to draw the ellipse. Okay, so I know this width here, so I might just I'm going to use a thinner pen maybe just to try to show the ellipse. Okay, I'll also make it a little bit easier for you to see by using a different color. So that will be that point brought down. So we'll draw, that's our minor. Okay, and then we know our major is 75 or 37.5 up from this. And again, that's another slightly unusual measurement, and that it tends to be that when we scale things, we don't end up with half millimeters. Okay, but we'll mark it there, 37.5. Okay, you can see my little orange dot there. Oops. So our construction for an ellipse: draw two circles, split it into 60 and 30 degrees, or pizza slices as we sometimes say. And do our construction. So this is an ellipse that's standing upright. Okay, so we just have a look at how to solve that. Okay, so we flip this around all our different ways. Now, the most important thing when you do this, especially when the ellipse is standing upright, often people make mistakes, is to mark the points that you want to start and finish from. So I'm just going to take a light green, or maybe this sort of like teal colour, and mark. So basically it's going to go from here, up to here, over to here, and down to here. Okay, so just make sure that you have those points marked out. So the reason I say that is when I draw this, the most common way that people would do this is because the oval is usually, or the ellipse is usually sitting on the right, to mark those two there. Okay, and you can see it couldn't go from here to there, right? So it couldn't go around that way, it wouldn't look right. So it must be the opposite way. And there's no harm in drawing both answers out and then figuring out which one is the right way. Okay, especially because this one here doesn't, from that one there, you wouldn't be obvious that that one is incorrect. Okay, and the same as that when you draw this, it doesn't have to go through that point. So basically the bottom ones are incorrect, it's the top ones that are right. So once you figure that out on one side, it's usually, you know which ones are right on the other side. Okay, so again, if it comes through this, fair enough, but if it doesn't, it's not meant to. Okay, and they've drawn that solid, I'm assuming, because this is see-through. Although, oh no, I was going to say, although if that's the case, it doesn't make sense what this is. It does, because this is a golf ball, and you wouldn't see the base through the golf ball. Okay, so we'll sketch that in. Then I'll repeat that. So I know it's this way. So it's basically, it's coming from the small circle, or sorry, from the big circle, it's coming out the way, or in the way, and from the small circle, it's coming down the way, or up the way. Okay, now it doesn't matter if you draw it, do both of these constructions on every single side. It wouldn't really make any difference. As long as you use the right one. So I'm happy with that. So what I'll do now is sketch this. Okay, so that's that bit done. So the last bit then, we have our front view done, we have our top view done, except for this curve here. Okay, so what we know basically is if we slice this here, it's going to give me a parabola shape. Okay, so if I slice that at an angle, that shape there is going to give me a parabola. So what I'm going to do is I'm going to construct a rectangle around this, and from that we put in my parabola. So I'm going to use a different color. Hopefully this luminous green looks okay. Let's see how that comes out on the projector visualizer. Maybe we'll go back to the teal. I feel it a little bit light for some people. Okay, so what we'll do is we'll draw this. Okay, so we know this height here is 50. 50 divides easily by 5. Okay, so 10, 20, 30, 40, and we'll do the same here, 10, 20, 40. Okay, so you can see my little blue dots there. And then on this side, it's, oh sugar. It's not that point I should have wrote it. Well, it is. Oh yeah, they're both the same. Okay, but it's not, it's a distance that we don't know. Okay, so what we'll do is we'll do a revision line method. I'll just use a thinner pen. Hopefully this doesn't go off the edge, but you should not do this. So I'll go 5, 10, 15, 20. And we'll join that up. And we'll use sliding step first. Okay. And I can just bring up those points straight up to the top because they have to be in the same spot rather than me having to draw them out again. Okay, and again you should be looking at them just to look that they look even, but they look fairly good. So we'll join these down to here. Okay, and then these ones here have to go. Hopefully they're not too thick on the draw. Okay. So where the first one crosses, the first one gives me a point, second one crosses the second one, third one crosses the third one gives me a point, fourth one crosses the fourth one gives me a point. And as you can see, like there, it pretty much starts to blend in with the ellipse once you get so far. So you see the first one crosses the first diagonal, second one, third one, and then by the time it gets up to the fourth one, it's pretty much blended. Okay, now again, the thickness of my marker makes it a little bit difficult for me to show exactly, but by the looks of it, basically by the time it gets to the fourth one that it starts to blend in. So that's the first bit A and B done. So what A done. So the front view and the top view done. So what I'm just going to see before I continue on is just, do I have enough space? So I need, this is 100, and I have 100 space, so that will work. Now do I have an adjustable set for handy? I don't think I do. So that can use, oh no, I have one here. Okay. So sometimes I don't use my adjustable sets, or particularly towards the bottom, because it's hard to work with that on an A3 board. Okay, for you should have an A2 board, so it should work perfectly fine. So I'm going to set my adjustable set square to this angle. So in order for me to look at the development of the cut surface, there's a few ways. I suppose I could rotate it up, right? Then I'd have to project it back down here, and then I'd have to extend it out, which probably wouldn't be a bad way. I could also do an auxiliary here, which would be typically what I would do, but we haven't covered much auxiliaries, because we have covered rotation. So maybe we look at the rotation method actually instead. It might be a simpler one to understand, and maybe I'll use a purple or something. Do I have the light purple? Let's start with this one here. Okay, so I'm going to use the rotation method. Okay, at a later stage I might come back and look at the auxiliary method. So this system is at an angle at the minute, so I want to rotate it down here, so basically that I can see it here. The other option would be I could rotate it this way. No, I'll leave it where it is. I'm just trying to think, if I rotate it that way, I'd have to reconstruct. It would actually flip backwards. Maybe we'll go that way. Maybe we'll rotate it this way. So, okay, so we'll go with this purple line. Okay, so we can ignore the other one that I have there on the top. Okay, so what I'm going to do is I need a series of points. Okay, so this one might look the best. So I'm going to mark the points that I have. So where all these crisscross. So I'm going to try to just sort of highlight them with an X, just so that they can be seen on the visualizer. Now this is a little bit difficult because of the thickness of the markers, and because of the amount of detail that's in the one spot. But if I want to label them, I'll call them point 1, point 2. So basically I have 11 points there. Okay, so the first thing I need to do is I need to get them up here. Okay, so point 6 is handy. There's point 6. Point 1 and point 11 are handy because they're there. So I'm just going to mark them here. I'm not going to bother drawing a line up, just for the sake of I suppose making it a little bit less things on top of each other. So there's 5 and 7. There's 3 and 8. So what you'll do is you'll see that there's points on top of each other. Sorry, not 3 and 8, 4 and 8. There's 9 and 3. So I should mark it first. 9 and 3. And there's 10 and 2. Okay. So 10 and 2. So there are my various points. So the first thing I'm going to do is they're up at this angle, so I'm going to rotate them down to be flat on the bracket. Okay, so my pivot point, the point at which rotating, is basically point 6. We rotate the largest one. One, 10 and 2. It would also work to use this as a pivot point and rotate them up the way, but this I suppose might just make it a bit easier to see. Just consider this is sort of new to us at this stage. So what I'm going to do now is with my thinner pen, I'll bring all these down. So all I need to do now is just bring out the points to meet them. I'm just making sure I'm going down far enough. Okay, so 6 was there. Okay, so 6 didn't actually pivot. 5 and 7 will come out to meet 9.5 and 7. I get my purple marker. 8 and 4. That 4 is the purple marker is a little bit hard to write numbers because it's a bit thick. 9 and 3. So what I'm doing here is I'm literally going, well, that was 9 and 3, bring it round, that's where 9 and 3 is. 10 and 2. And then lastly, this bit here has to be the same width as it was. So 1 and 11. Okay. So there's basically the true shape. So mine might be a little bit more pointy at the top than yours, just because of the thickness of the markers. Okay, so what that is there is basically the true shape of the parabola. So if I had to cut, I don't know, a piece of glass or something to fit into that, that would be the shape of what it would be. Okay, as I said, yours might hopefully be a little bit less pointy than mine. And that's the question completed. So just move the set square just so that you can see it there. There, as I said, there is an alternative way to do part B, but what we've done there is a perfectly acceptable method, rotation method.